Hi, in this lesson, we'll focus on debugging our physical circuits. For much of the course, students will use built-in sensors on their microbit, which will not require much physical debugging. In the following lessons, they will connect external devices to their microbit, which will bring about the need for physical debugging strategies. In Lesson 1.4, Variables, they will connect an external LED. In Lesson 2.4, If-Else Statements, they'll connect a servo motor. And in Lesson 2.5 Functions, they will connect a rangefinder. Once students reach the final module of the course, they will also need to use breadboards to complete their circuits. Though this board is very helpful in keeping circuits more organized, they bring about their own set of issues that can arise. Debugging is already a lot of work, but once you add a physical component in addition to your program, there are twice as many places your bug can be hiding. In the last lesson, we discussed the debugging process, where we look for an issue and try to fix it. With the addition of physical components, we actually need to complete this process twice. We start by writing our program and use the circuit simulator to test its functionality. If we notice an issue, we debug our program at this stage. Once our program works as intended on the simulator, we build it out using our physical components. When we run the program on our physical device, a whole new set of issues can arise, so we may need to debug at this point as well. The first debugging process will happen in the Make Code editor with the microbit simulator. The second debugging process will happen once the program is uploaded to the physical device. Debugging physical circuits can get complicated. Let's look at a few strategies you can teach your students to have them solve their own problems. First, if students are at the stage of the course where a breadboard is used, this is where students should start. Students should revisit the image or step-by-step directions to make sure all connections are where they should be. We then want them to check all the ground and power connections. Are all the wires that are connected to the ground rail correct? What about those connected to the power rail? If possible, it can help with organization if every wire connected to the power rail is red and every wire connected to the ground rail are black. Next, they should check all the connections on the inside of the breadboard, remembering that all ports A through E and F through J in each numbered row are connected. If they have a component plugged in to an A through E or F through J port, they should also have a connection in one of the open A through E or F through J ports in the same numbered row, because this is the only way the connection will continue. Next, students should keep the individual components in mind. Here are some helpful tips. LEDs only work in one direction, and it is very easy to mix up the placement of the long and short legs. A quick fix to test is to pull the LED out and switch the placement of the legs to see if that fixes the issue. Resistors are very fragile and have long, flexible legs. This can sometimes make it difficult to push legs fully into the breadboard ports to make a full connection. Pull the resistor out of the port and carefully insert it again, or trim the legs to make it easier to connect to the needed ports. Many sensors have multiple pins that must be connected in a specific way. Students should double-check these pins and their requirements to be sure that they are all connected in the proper place. If all else fails, a good way to check if you have a faulty device is to replace the one you're using with another. In this lesson, you'll explore these strategies to practice debugging sample circuits. Let's go!